Good evening, everyone. Before we begin today's session, could you please confirm if you can hear me? You can type it in the live chat box on the right-hand side. Okay, great. Thank you for confirming. So good evening, everyone, and welcome to a new year of the Formula Bharat Academy series. Today, we have Suhas Rajkumar, founder of Simple Energy, who shall be presenting on the topic EV components that can be made in India and the future of EV technology. A bit about Suhas. He has a background in architecture and he aspires to be an inspirational leader. His startup, Simple Energy, aims at building smart, long range, affordable urban electric vehicles which have fast charging time. At Simple Energy, Suhas drives the company towards growth with his innovative ideas, strategy, design, and passion for innovation. His goal is to make the firm a globally recognized Indian brand. So, without further delay, I would like to invite Suhas to take over the rest of the presentation. Suhas, please go ahead.
Well, thank you. Thank you so much for that introduction. Amazing to be connected to young guys and then sharing a few of my experiences and also about how we can grow together in terms of building things in house, in the sense indigenous, and start looking at Indian automobiles in a better way, which world can look up to adopt, and we can become leaders in that front. So just to uh, revise on that part, that I happen to accidentally come into this, and that's how I have grown in experience. So opportunities are limitless. So anyone can jump into anything that they want, but it has to be filled with passion, and that's how you can explore new things. So it doesn't have to be the marks. It doesn't have to be academic excellence. It's all about how we can pursue a dream or the kind of urge to learn. That's how we can grow together. So talking at that point, to begin with the session, I would like to first share my screen so that I can start the presentation.
Suhas, if you'd like, you can turn on your video as well. I had to shut it during the
Sure,
thumbs up.
I did.
Sure, great.
Yeah, so I hope my screen is visible now.
Yes, it is.
Great. So talking about components of an EV that can be made in India and the future of EV technology, right? So just to begin with an introduction, what will this session cover is it'll be majorly focused on what are the kinds of powertrains that are the elements that we can really work upon. Because a lot of technology, if you look into the kind of adaptability is there in the market today, it's more to do with the technology that comes from the Japanese side or Taiwanese or Chinese majorly. So, or German for that matter. So a lot of these components are manufactured there, they're bought down here, and the price goes up. So it is much more difficult to manufacture those components here as it. I mean, that is the force, but I believe otherwise. And it's much more difficult to put them into an affordable category. So these are the challenges that EV industry faces as such, and also an initiative to make it let's make in India, right? So that's one of the initiatives apart from making it affordable. And also cover what are the future, what is the future of EV, and all sorts of opportunities that this industry has to offer. And then we can go ahead and take questions on that part, right? So coming to the introduction part of things. So why EV? What is electric vehicle? So electric vehicle is something that works on electricity. So just to give you a basic definition of that part. But why is there a drive towards pushing to EV? First thing, sustainability, because a lot of our resources, naturally, are depleting at a faster rate. And today, if you look at the global warming rates, it's alarming, and a lot of things have gone bad in the past decade. Actually, we have uh, gone ahead depleting the natural resources at 2x times in last decade, so which has put up a lot of pressure on the planet that we call earth. And that's the reason we have to push towards sustainable products, or so or any kind of energy that is available, so that we can start saving the environment in a very good uh, for the future generations at least. Then comes the pollution part. If you, I'm sure everyone has looked into it, that pollution is one of the key issues in Delhi, in Mumbai, in metropolitan cities as such. And this has been around the global. It's a global phenomenon which kills a lot of people every year. It is one of the major concerns right now. So the Paris Pact that was done accordingly to reduce pollution and get more sustainable automobile out there, because majority of things also come from automobile industry. The carbon footprint is very high, so we have to look into that aspect. Then comes renewable resource of energy, because there's abundance of that in our world. So we have to try and look at options where we can use solar energy, where you can use natural resources and convert them to a renewable part of things. Electricity is one of things. Looking at hydropower, look at all other aspects that can really help us move towards sustainable future, and can help us develop better products, right? So next, Indian EV industry. What is the market like? So when you look at the market, it is huge. There are 2 crore vehicles that sell every year, two wheelers in particular. So that is a huge market. If you look at the sales figures of every other giant, like Honda Activa, everything, they sell around 25 lakh vehicles. So that's huge petrol vehicles that are selling out there. And there's a lot of standpoint there that EV is available, EV market is available, and we can really tap into this and make this a very, very good drive towards sustainable future. So when it comes to technological parts, right, I'll brief you on that part first. When we look at technology in terms of EVs, India is not that ahead in terms of that, right? If you look at major players, if you look at major companies that are coming with EV products, the complete powertrain is outsourced. Companies like Bosch, companies like Mahle, companies like other companies as such, we can name it, which are Chinese, which are German. So everything is outsourced. Majority of the powertrain is not done in house, including the cells. Right, cell is one major factor that adds to the complete cost of things, and a lot of lithium-ion cells are not, done in India. So they're manufactured either in South Korea, they're manufactured in Japan, either manufactured in China. So China holds majority of the OEs, right? So this is a kind of a prime concern in terms of technological advancement that we should have. So in global standpoint, we are still far behind in terms of that, and we'll have to look into technologies which can be developed indigenously, and we can dominate the global market in terms of EV revolution. And also there's a need for self sustainability. So we import huge petroleum products, oil, so which is again economical downside for us, because we invest a lot of thing on that, and we need to start developing products in house, so that we stop our dependency on the global oil imports, which is that money can be used in building infrastructure for EVs. It can be used in education. It can be used in getting our health sector stronger. So these are the other aspects of why we need to be sustainable and self-reliant, rather than depending on a global, depending on a non-national company, which is a foreign company, which provides all other powertrains that is required for an EV to operate. Right. So this is the kind of market that is available today, and we need to look into that aspect very, very clearly. And for that, we need to start developing components which are in-house and which can power our EVs that we develop in the next upcoming years. So that is the importance, and that is the kind of market that we have today. Then coming to the main topic, that is let's make in India. So when we speak of let's make in India, it's just not a word for pushing the local talent, or trying to tell that, let's start putting India in front of the technological advancement. It is more to do with how do we get our economy, how do we get our technologies, how we get our human resources to be to get it in a certain way that we can really put things ahead and stop depending on foreign technology, so that when we manufacture India, the job opportunities are huge. The local talent stays here, they don't fly out. There's more opportunities here, better companies come in, a lot of business comes in. We grow as a company. We can outsource the technology rather than taking it from the outside and start looking at the world as a leader rather than more of a taker, and using others, whatever that they have developed, and start depending on them again, because that doesn't really make sense. If you're importing oil, then we'll start importing the powertrains. That really doesn't add value to things and doesn't really make in India. It's just that you're importing things and trying to manufacture things here, which is outsourced, right? Manufacturing and also developing has to be two things. R&D and manufacturing has to be in India. R&D is the key. We have to invest a lot of time in that. It is not easy. It'll take a couple of years more. It might take more years, but we have to focus on R&D. We have to invest a lot of time and resources into R&D, so that we develop a product which is really in the actual sense, which is made in India and make in India as well, right? Though, so understanding the heart of EV. When we speak of heart of EVs, right? So what are the components we can actually manufacture in India? So if you look at the mechanical side standpoint, automobile industry, it's almost 100-year-old industry, right? Majority of things are already there, like the whole vehicle chassis, the plastic designs, the lighting solutions, the rims, every other mechanical components which is done is already available, right? It is already there. There's nothing new that is not being done in India, and everything can be designed and manufactured easily. What we really don't manufacture in India is the battery management system, the motors, the controller, the charger, and the complete powertrain, right? So the battery has two components to it. One is making a battery, and second thing is assembling a battery, right? So when we talk about make a battery, it involves making the cells as well. When we talk about assembling a battery, it involves we are outsourcing the cells and we are manufacturing the battery here, right? We are assembling the battery pack and making it to we are assembling the cells and making a battery pack, adding a battery management system, and then outselling it to the manufacturers or the people who are adapting to that. That is something that is a mix of things, but it's not the wholehearted battery. So when we speak of battery, it starts with manufacturing the cells itself. It can be lithium ion, it can be solid base, it can be any other technology that we can start developing on. So primarily right now, what is tested and trial? That is lithium ion, right? So there is we understand that there's the cores are not the China controls the lithium resources all over the world. But again, we can move into other things like iron. There are a lot of components which we can really look into it, so that we start developing technologies in terms that we can manufacture cells which are not dependent on lithium ion. Aluminum air cells are there, and there are different kind of technologies that are come into the picture, but which are still R&D. So it is an importance in a way that so that we stop depending on lithium ion and start looking at alternate battery cells which can power our vehicles maybe better than the lithium ions. Typically, if you look at a cell, it doesn't have the density that is required, right? If you use a 2.9 or 3 kilowatt of battery pack, it won't give you more than 100 kilometers of range. Whereas if you replace it with air fuel cells, it can definitely give you 3x, 4x kind of density, which can give you better range and which can be easily adapted to into two-wheelers or three-wheelers or cargo vehicles or any kind of automobile that you want to talk about. So still in early stage, but we can definitely do a lot of things in that, and that is a really important part of the whole ecosystem. So when we start focusing on the battery the battery packs, it comes with a battery management system, right? So I don't know if a lot of people know about this, but India does manufacture a lot of battery management systems for outsourced companies. So a lot of manpower from India is working on that part, which is not in the use of Indian technologies, right? So there is a lot of advancements in that part, and also India is Bangalore is basically IT hub of things, right? Software. So when you talk about battery management system, right, it has two components. One is the embedded part of it. One is the hardware part of it, right? Power electronics part. So when we talk about hardware part of things, there's a lot of challenges in that. A typical battery management system with smart features which can control the battery pack, SOC requirements on it, telling the kind of battery responses, the kind of the whole system architecture that has been developed is difficult part of things, right? Hardware and software has to go hand in hand. So this can actually leverage us in terms of how we can develop a better battery management system and start supplying this architecture, which is combined with a smart app for reading, or maybe a software which can complement that, and we can start implementing this in other foreign companies and outsourcing this complete technology to them. So battery management system is also key, because that's the brain of the battery, and we can if there are a lot of avenues, we can definitely look into this part of it. Battery definitely is the first priority, but if it's something that is to be delayed upon because of few restrictions and a few challenges that come along the way, so there's a lot of time for battery advancements to happen. So we are in a very nascent stage right now. So that will take time. But what we can really work on thoroughly is battery management systems, which can be universal, which can fit in any vehicle that you want. You can design the embedded architecture in such a certain way that it complements any kind of battery pack that is required. Of course, there are challenges with the restrictions to it, but again, we can really look into it. And there are a lot of opportunities on that part. A lot of young talent can come in and start developing and learning about what battery management systems are, because the world needs smart solutions, smart batteries, AI batteries for that matter. So this can actually put a lot of things ahead, and we can ask a lot of companies to adapt our technology, and we can make a lot of advancement in that. So this is one of the major components, and I think the most critical component of a battery, that is a BMS. So we can, and actually there's a lot of opportunities here. PCB designs, take it any big mobile manufacturers for that matter, right? Many mobile manufacturers have shifted to India, so a lot of people have started looking into that. So PCB designs, hardware manufacturing of this kind of circuit boards is not really difficult. We have the infrastructure. All we need is an intent. All we need is the right solution, the right approach on the part of that the whole ecosystem is facing, and develop such technologies that people can from foreign companies can adapt to this, and we can start moving on that part. Now coming to the main part of things, that is a motor. So if you look at Indian ecosystem, a lot of EVs are Chinese, right? 90% of the EVs are Chinese, and they come with two types of, one is hub motor, one is the mid-drive motor. Mid-drive motor also has a radial and axial, but let's not get into that part as such. But there are two types of motor majorly used in automobile industry, or two-wheelers majorly, that is a mid-drive motor and a hub motor, right? Majority of the Chinese scooters are hub motor, majority of them, because mid-drive motors require a lot of engineering, and it is most difficult task. Hub motor solves the whole purpose. It reduces the cost. You can fit it in easily, but it's not really dependable. It is not reliable. So if you look at all this, major motor suppliers are from China. India, according to our experience, India's infrastructure.
Hi, Suhas. I believe you've gone on mute. Hi, Suhas. Can you hear us?
Yeah, I can.
Okay, great.
So I can.
There is a feedback.
Hello.
Yes. Is there a separate application open? Perhaps another YouTube screen?
Yeah, it is.
Okay. That is probably why we're hearing you twice. You might need to just mute that.
1 second.
Okay, great.
Yeah. Now it's fine.
Yes, yes.
Okay, great.
Please go ahead.
Yeah. So,
Yeah.
sorry for that.
No problem.
Yeah, motors. When I was talking about the motor part of things, when we look at the motor ecosystem in India, it is very poor. The manufacturing feasibility in India is a bit low, uh, because there are not a lot of vendors who are willing to manufacture motors. There's not a single notable company which is into motor development apart from Bosch or Mahle, but these companies don't come from India, so they have their origins on different countries. So a lot of dependency on motor is from these companies, and we have faced challenges on that part. So there's a lot of opportunity on this part, right? So we can start developing motors for more of a cargo solution, where we can try and develop hub motors locally, so that the prices are coming down. We are having our own technology on that part. We own the whole powertrain on that part, right? So we can start looking into motor development as one of the key features, and also an opportunity for Indian-based motors rather than depending on different kind of companies which are supplying as of now, right? So on a whole, the notable companies which motor is being procured from are majorly from China. Any startup, any kind of big company starts looking at China because they already have a ready-made motor. The kind of motor, they have variety options from 500 watts to a 25 kilowatt, or maybe up to that. Two-wheelers majorly require a 5 to 3 kilowatt hour motors, but you have varieties of options, different kind of motors available at a price point that you need. So this is the kind of ecosystem China has created. So motor development requires a lot of engineering. It requires a lot of data going into it. We have to design the starters, we have to design the rotors, we have to design the kind of bearings, the kind of heat dissipation systems, the kind of casing. So a lot of these components come into the picture when we develop a motor pack, right? And it has to be done specifically to a specific industry. For a two-wheeler performance-oriented bikes or scooters have a different kind of requirement. Cargo vehicles have a different kind of speed requirements or torque requirements. When you look at the heavy-duty vehicles, they have a different kind of requirements, right? So there's huge opportunity on this part because more or less controlling a motor part controls a lot of efficiency on the powertrain. And it is very important that we start developing motors. And it is very, very critical component. And to bring down the cost, we will have to look into this components, because typically a motor would cost you around 1.3 lakhs, a 5 kilowatt of motor with a controller as well. So that is a huge cost when it comes to one single purchase. But if you go at bulk, it will cost you around 50 to 60,000 rupees, right? If you outsource. But if you start manufacturing, this can drop down to around 10,000 to 15,000 rupees with the controller part of things. So we need to look into that part. So motor is one part of it. Controller, there's other name for it that is called inverter. So control inverter, whatever we can name it as. So when you talk about the controller, it is the brain of basically it is the brain of the motor. But at the same time, it communicates between the various systems, the VCU, the battery management system, and the throttle input that we give in, right? So it also comprises of embedded systems and also about hardware, right? It involves both the things. So we need to have a particular architecture on that part. There's a lot of technology advancements that's going in controller part, because there are different requirements on different things, right? So there's a lot of opportunity on this part. So motor and the controller come in hand. So it is a lot of interdependent components. So we can look into that and start developing our talents in based of that. So anyone who wants to develop a performance-oriented vehicle, it has to be based on this motor and controller, because this gives you the torque and the RPM that you really want. And this is the kind of innovation that we would look at, because these components decide a lot of performance. It also decides a lot of range aspects of things of a vehicle. So motor controller is definitely the most important. I would say the highest priority right now should be to develop motor controllers, because battery and BMS is already there, but this kind of components really it's not really present. It's something that we also as startup have faced, and that's why we started developing our own things. But again, yeah, there's a lot of opportunities. It's a $1 billion industry. So yeah, new talents coming in, new technologies coming in, which only help develop better motors, efficient motors, smaller motors, lightweight motors, which can give you the kind of performance, the kind of reliability required on that part, right? So if anyone is aspiring to get into control systems, the kind of control systems that we can develop can be implemented in any kind of field. It can be in space technology, it can be in EV technology, because a person who can work on control systems is experienced enough to work on different kind of control systems, right? So this is something that people, any aspiring student can focus on to learning. He can focus either on the embedded part of it or the hardware part of it. So it can be any of this. Then comes your charger part. Again, there are a lot of dependency on charging stations. Fast chargers are the need of the hour. So we need to develop a universal charger which can have, which can take in any kind of vehicle that is required, depending again on the kind of manufacturer as socket connectors are, or the male and the female adaptations are, right? The male and female connectors basically I'm talking about. So yeah, we can. There's a lot of opportunity here. We can start developing our own chargers, which can give you the leverage of fast charging technologies. A lot of foreign companies have that part, so we can look into developing the hardware and the embedded for this as well, and program it in such a way that any EV can charge in that sense. It is universal, more to do it than a closed network. So we can definitely. There's a lot of opportunity on that part. It is more to do with the kind of hardware and the embedded that we develop. It's majorly the hardware and the kind of connectors we use. I'll give you a small example. If we have to outsource a connector, for example, I mean, 2 years back, when we had to outsource a connector, it would cost you around 14,000 rupees, a small connector. It is a very small piece of hardware. It cost you around 13,000 rupees for plus other taxes. So, which is a very, very high cost. And when we start manufacturing it here, the cost would come down maybe 10x times. So it'll be around 1,300 rupees, right? So this is the kind of cost difference that comes in if you start doing things in house, and we can make it more affordable, we can make it more accessible, and we can supply it to majority of the players, because a lot of automobile manufacturers don't really focus on charges, because charge is universal. It can be 1 kilowatt hour charger, it can be a 2 kilowatt charger, it can be a 3 kilowatt hour charger. Typically the handy chargers are 700 watts, so that is a type of charger given. That's a slow charger. But if you want to charge it, depending on your C rating, if you want to charge faster, then you'll have to have a higher kilowatt hour charger. So typically Indian households can handle 3.3 kilowatt hour charger, but on a public platform, it can be a 10 kilowatt charger, it can be anything of that sort, however max you can go. So which can start, which can support the cars also, we can support two-wheelers also, four-wheelers and two-wheelers both, right? So this is a huge opportunity here as well. The infrastructure is still, I would say, very, very, very early. There's not a lot of charges we see. So because there is a dependency on a lot of things. So opportunity here, some advancement in this compact charges, handy charges. If someone can look into that part, will be amazing, because lightweight charges, portable charges are the need of the hour. A lot of EV owners would love that, because they can keep it in the boot or their car boot or two-wheeler boot and still carry it upon. And if it is a fast charger like a 2 kilowatt, 3 kilowatt charger, that's amazing, because you can charge a scooter in 2 hours, right? So that is the kind of need of the hour, because right now it is 700 watt, it is heavy, it is not really appealing. So that's the kind of technological stage that we are at, but we can develop better charges, and that is an opportunity that we can look at. So when it comes to powertrain involves your chain drive also. It involves your belt drive also, right? So if you look at the downsides of belt drive, and if you look at the downsides of chain drive, firstly, downside of the chain drive is the kind of what do you say? The reliability is a bit low on that part, but again, it gives you a lot of efficiency. And the cost of making us is low. Powertrain doesn't involve only this; it involves the above battery, motor, and control as well. So just to add that point of summarizing that powertrain, so we can also look into belt drive, but again, it is costly affair. We have to it'll cost you typically around 5 to 6,000 rupees at mass, even if you have to do a replacement cost. Whereas a chain drive would cost you around 1,500 rupees, right? So, but belt drive is less efficient than a chain drive. So typically, it is a choice of the company or the kind of powertrain that is required and the kind of operation that we're operating, right? So this is the typical heart of an EV, and a lot of innovation. Powertrain is something that we can really. It's something that is not really. I mean, you don't have to really focus on part of things, because chain drive and belt drive are anyways the two choices that EVs are good at. But that is something that is something that is manufacturable easily, and it is also cheap already. So talking about this is the heart of EV, which comprises of this, and without this, there's no other major component that comes into it. Going forward, the VCU, the brain of things, the vehicle control unit, which is not actually deemed to be as hard of an EV. It's more of a controlling system, which is a different topic altogether, which is already developed in India, and there's a lot of advancements on that part, right? So a lot of chips are there. a lot of processor units that we can get it from Indian companies itself. There's a lot of advancement in that part. We can adapt easily and start using them to better the whole powertrain or the heart of the EV that we call it. Yeah. Then more information on opportunities, why make in India, and challenges. So I think typically why make in India, because firstly we need to start being reliable. We need to start developing technology. So we outsource and rather than import. Opportunities, yes, it's $1 billion opportunity. Be it developing the whole EV or be it developing EV components. Right, both are handy. Both come in, both complement each other. Because if someone is developing the whole metal part of it, he would require the components like battery management systems, the batteries, and other aspects of things. And definitely, that's an opportunity there. So so we can definitely look into that aspect as commercial point of view. If you look at technological point of view, then we will have to make things in a very aligned way, so that we invest a lot of time and resources in R&D part and develop such powertrains that can be a commercial success, and which will make EV more affordable in a long run. And it can definitely build up a lot of job opportunities. It can create a lot of enthusiasm in terms of R&D in India. A lot of students will be interested in taking part or joining such companies which are working on these technologies, because that is again the future, and that is how the opportunities are created in terms of adaptability in the mass, right? Then coming back to the challenges, the major challenges, because EV is new, a lot of people are not experienced enough in terms of the powertrains development a part of it, because it is something that is not known to the world as such. EVs have taken center stage in last one and a half year recently. So there are a lot of challenges in terms of human resource. So a lot of opportunities there. A lot of companies, EV companies, want amazing talents who can really work on this, and they're looking out for brilliant students or employees, you can call it, or teammates, you call it. So that is one part of challenge. So we need to start looking at EVs as an opportunity more than no game, or something that really won't work out, right? Then comes to developing the supply chain. The challenges on the supply chain are huge. So we are not really at par when it comes to developing the heart of EVs, because the supply chain is weak in India. So we are a lot of dependent on other countries, and anything like pandemic happens, the whole supply chain goes down, and the cost matters also, right? So we cannot control cost because foreign costs, import costs are high, and that's the reason the EV goes up. So we need to really innovate on the supply chain matters, make our own supply chain stronger internally, and make it more indigenous. And other challenges are, it takes time. There's a lot of patience required on that part. There are failures on that part. So developing motor controllers, BMS, battery packs, cell, all this are very, very tedious tasks. It requires precision, it requires patience, and it requires a lot of time. So this is one of the key challenges that people face. And also in terms of support system, right? So a lot of companies have to be, a lot of companies or institutions have to focus on, giving opportunities to develop new technologies, being in the racing teams, being in terms of college projects, so that there might be more hands-on experience on that part, and we can start giving the young minds the infrastructure required. Because today we see a lot of infrastructure is absent in terms of developing EV the heart of the EV part, right? So this is the kind of challenges that is right now being highlighted, and we need to really think about this, and hopefully EV players, institutions, a lot of people provide the infrastructure required and the opportunities required, so we can overcome these challenges, which are not really great. As if you look at in the long term perspective, it is not impossible, it's doable, provided we have the clear mindset, the kind of approach that is required, and we can start looking at that in a very, very positive way, right? Then the future of EV technology, when we highlight the future of EV technology, it is more to do with the kind of opportunities that is being provided with powertrains. So yeah, future of EV technology is more dependent on the cell technology. So it can be lithium ion, it can be solid based, it can be graphene based, it can be any kind of cell technology that is there. So that is the future of EV technology. And if someone wants to venture into EVs, then I think the right opportunity there is to develop battery packs, to look into developing cells, and to look into developing the motor and the controller. So these are the three key areas where you can focus on. Battery packs are different from cells, so that cell technology can be it can be applied in any kind of industry. It can be in computer industry, it can be in mobile industry, it can be space industry, it can be in military, it can be anywhere. So cell technology can be anywhere. Battery technology also can be implemented in energy storage, in renewable energy storage, and all the other aspects that we can look at. So, but it needs a lot of what do you say, better understanding the better output of the BMS. Part of the architecture of the BMS needs to be well designed so that the pack itself behaves the way it is required to behave. And that is where opportunities are there. That's where the future of EV technology is going forward. So yeah, so three key components: one is battery, one is cell technology, and one is motor control and technology. So these are the three key main areas that we need to focus on, and these are the heart of things. And any company, any institution, any team which controls these three things can control the outcome pretty much to a very great extent. And that is how the whole thing moves forward on. And India needs to focus on this, and Indian young minds need to focus on these three things, because that is the future EV technology. And if we are successful in doing that, I mean, we can definitely dominate EV industry in next 5 to 10 years. And that is how the way forward for EV technology is. And with that, few insights I would like to give the highlights of things in industry trends. If you look at competition, adoption, and range anxiety, and catering to the pain points, I think that is the kind of EV trend as right now going. There's a lot of competition coming up. There's a lot of adoption in terms of EV technologies. A lot of people are looking at buying an EV. Range anxiety is one of the key issues which every other company is trying to solve. And there'll be technological advancements really, really soon in that part. And we will definitely, we can definitely cater that part of things through our technological development or the manufacturing that we can do, which is motor controller, battery packs, and BMS. Then comes to the catering pain points of the EV industry. That is the value for money, small, short ranges, non-reliable products, boring designs, and things like that. So these are the catering of, we can really look into pain points of EV customers or people who are really wanting to buy but are backing off because of few issues. So we need to really understand that. And this is the kind of, benchmarking that we can do in terms of understanding the problem statement. Technology advancement to change, foresee, then easy of adoption, software, right? Advancements, as I earlier spoke about, that we need to start developing things in a better way, efficient way, smaller, and also in a way that it can cater the market needs. And we need to start looking at the changes that is going to happen and not stick to something that is already there. We need to start looking at change and also make things in a way that it is very, very easy to adapt rather than something that is very complicated. People want to really look at things which are replaceable easily rather than something that will put them out of the comfort zone. Software, yes, software. As I speak of embedded, it is a very important thing because it decides a lot of key factors in the core heart of the EV. So software is something that need to be focused on because that comes in hand in hand with the hardware part. And charging of EV, how can it get better from the EV perspective and consumer perspective? Because today charges are slow. We need to give more portable charges rather than a fixed charges, so people can really stop depending on fast charging public networks. Rather than, it can be a mix of a balanced act. So that needs to be there because today it has to be very, very balanced, consumer friendly charges. That is one part of things that we can look into it. Then government support, of course. We can start looking at the kind of policies that have been framed, FAME 1, FAME 2, the regulations that are coming in. So these are the key government aspects that come in. Government is stepping up their game in terms of EV support and trying to pull in customer-friendly, customer incentives, so that when you buy, you have incentives on it. A lot of aspects on that part, and other parts of innovation in EV itself. It can be AI-based systems which can adapt, which can learn, which can give feedbacks on the kind of the driving pattern. It can start learning from things and can give you the real perspective on that part, right? Then comes to export more than import. That is the manufacturing philosophy that needs to be adapted on. It can only happen if you have the technological advancements required. and we have the kind of things. And we should look at battery and cell and human capital, because if you look at human resource today is in terms of EV awareness, it's a bit on an nascent stage. So we can look into training a lot of young minds in terms of that and encourage them to develop new technology at a very young age, so that we start developing new technology, and then that export more than import philosophy can come into picture, and we can start looking at the world as EV leaders rather than more of an import country, right? Yeah. So this is more of my uh, presentation on the part of what we can manufacture and what kind of EV challenges and technologies that we can look forward to. And I would look forward to taking up any questions that you would have, and I'll be more than happy to answer. Thank you so much.
Thank you, Suhas. I'm going to add the Excel sheet, the spreadsheet over here um, in the chat box. And,
Yeah.
okay. You can stop sharing your screen as well if you'd want, or you can keep sharing the slide,
Sure, I'll do that.
whichever one. Yeah. So, would you
Yeah.
like me
So I
to?
have.
Most of the questions are on Simple Energies Mark II. We do have a few questions from
Yeah.
Sanchit at the bottom, which are about motors. So you can go ahead with starting whichever one you'd like to answer.
Sure. So when is Simple Mark II releasing? Mention the release date or month. Okay. That is something that is I can't really answer on the exact release date or month. It is definitely mid of this year, right? So that is something we will announce on our official pages, and it will be out there soon, very soon. Then comes to the second question: what is the price of Mark II, and how many types of models are releasing Mark II? So we are aiming at pricing it around 1.1 to 1.2 lakhs. Nothing finalized on that part, but we'll definitely make it more affordable, and definitely it'll be which can cater the mass market. So a lot of people are looking at that price point, and we'll definitely cater that kind of requirement that we have uh, observed and we think is right. Can we expect that mark? Third question, I think. Okay. Yeah, third question, fourth question is third question in my list. Can we expect that Mark II will have components which is manufactured in India? So as of now, we do around 85% of manufacturing which is done in India. So we control almost complete powertrain except the cells. We are outsourcing the cells, but going forward in 2023, we have plans to start manufacturing our own cells. So that is something that we will localize and will be 100% India made. So right now it is 85% localized. So we do everything on our own. We have invested a lot of R&D time on motor controllers, motors, and different kind of challenges, different kind of architecture that is required. So we have already done that. So 85% of the components are done in India. And when we buy a Mark II or when we launch a Mark II, will be with that kind of percentage. In the future, definitely aiming to do 100%. Then comes to expect battery major components of Mark II will be produced in India. Yes, we do battery in-house. We completely assemble the battery in-house. We have our own BMS. We have a patented technology on that part as well. So we control the whole part, except for the cells. We don't uh, depend on anything else. So yeah, we definitely do that in-house. So currently, are you making motors in-house? Yes, we are. We are working on a more advanced, smaller motors which can power our needs and which can be the base to our upcoming products as well. So that has been our key focus from day one, and that's how we control a lot of things, and we can control the whole product comfort and outcome as well. Can we add boosting systems in EV? Okay, you can definitely add boosting systems in EV, but it depends on how the architecture is, developed. So that is something that is really doable. So it depends on how you take it forward, and it has a lot of restrictions as well. So you can definitely add that. And coming to the eighth question, Lucid manufactures their own motors, while most Indian manufacturers procure theirs. Is the model that Lucid follows to expand for Indian market? What depends on resources? Okay. Yeah, Lucid definitely is a bit expensive. As I mentioned earlier, you can definitely get this motor cost depending on the kind of kilowatt that you want. A typical 3 kilowatt shouldn't cost you more than 12,000 rupees on mass. So definitely is expensive. And uh, the reason they are not able to match is because their dependency is more majorly on China's market, because magnets come from there, and that's something that needs to be resolved on, right? So that is the answer for that question. And then comes to, in order to achieve the massive range of 240 kilometers, was active cell balancing done? Active cell balancing done, that is part and parcel of things that is done in every EV. So that is something that is understood, and it has to be done anyways, right? To protect the whole battery pack and to have a balanced battery pack coming out, so it doesn't cause any harm or it doesn't burn out, right? So that is a part of the procedure. And does Simple Energy develop their own in-house BMS? Is it procured from a manufacturer? No. We manufacture our own battery packs, so we control the whole BMS architecture. So we control the whole embedded and hardware of it, and we have our own patents filed on that part. Yeah. Then comes what is your thoughts on new take on Porsche new synthetic fuel being more eco-friendly than battery? I would say that is in a very nascent stage. If that comes into picture with which can replace an EV's comfort, because if you look at today's battery technology, it took around 30 years to develop and come into commercial viability. So it is still in an early stage. So I would say it is too early to comment on that part. But if there's something better eco-friendly, which can be a better alternative than a battery-powered vehicles, then it's an amazing thing, and we should look to adapt the same. Is there any HVAC system implemented in electric vehicles? If no, why? It depends on the kind of cooling systems that we really look at, right? So I can't really comment on why others are not using it, or why it's not really implemented. It depends on how the whole architecture of the vehicle is, right? But there's a necessity of things. So wherever there's necessity, people can do it. If there is not, then there is not. But I think that is something that can be avoided, and it's something that is not really to be focused upon. EV performance takes a hit in hotter climates. Many startups test their vehicles which work completely fine in Bangalore but observe drops in performance in Chennai warmer temperature. Yes, if you look at the major, uh, R&D also is done on, kind of heat dissipation systems are, the kind of heat dissipation a battery pack can do. The thermal architecture is very important. So hotter the climate is, it does affect the vehicles. So it depends on the kind of R&D that we do in different cities, and we get an average data point, and we can start developing the battery packs, the kind of, you know, the complete, what do you say, the design of the battery pack. I cannot really reveal what exactly is done in the battery pack, because I can definitely tell you the kind of PCM material we can benchmark. We can start looking at, benchmarking different temperatures of different cities, get an average of it, start testing it internally, make better thermal systems, which can, aid the whole, you know, the temperature of the battery packs. Because if you look at loss of energy, it is a very concerning part of things. So that's where the major R&D also goes in, and that's what we are working on, having better naturally air cooled batteries, rather than which is aided by oil cooled or any other medium that is there, because that increases the cost again. So yeah, our focus is also on that part, that we develop, air cooled, more efficient batteries which don't lose performance in hotter climates. Is there any good Indian company which manufacture EV motors, especially for FSFE purpose? Most of them have the power but are very heavy. Yes, that's the point. We need to develop a very lightweight battery, because EVs need lighter frame. So as many components are lighter, that is better for an EV, because it increases the range and the performance as well. Uh, Notably, I have not identified any good companies which can manufacture such motors. So yeah, we really need to wait for that. Maybe there will be a company that will come along and give better motors for this purpose. Maybe even Simple Energy would do that and going forward, because we do everything in house, so we might mention that part as well. But there's a necessity that is required, and that's the reason I emphasize more on developing motors in India, and encourage a lot of companies to do that, which will be beneficial for the whole ecosystem. Hence, are liquid cooling systems a better alternative to passive fan-based cooling system? Definitely, because that gives you, very active cooling, which will help, increase the range and maintain the battery life cycle as well, the cell life cycle. But again, it is costly affair, which cannot be implemented. If implemented, then we have to compromise on the cost, and the customer has to bear that end of it. But maybe in the higher end premium vehicles like sports bikes or something which will cost you around 4 to 5 lakh rupees or 6 lakh rupees, there you might find this liquid cooling systems. But definitely it is a better alternative. But if we focus more on how we can work on the passive cooling, uh, complete architecture, the kind of placement of the battery, the kind of air intake, using fans and everything else, then definitely which we can reach closer to the what is the outcome that a liquid cool can give. So results can be closer. Uh, but if you look at the plain question of yours, then definitely it is a better alternative. Are you planning on a subscription plan for dashboard services? Uh, that is a difficult question. It depends on a lot of things, but it will not be something that is already there. It'll be way less, or it might not be there also. So there are both ways, but definitely be better, more customer friendly, and not nothing like what the competitor today has or any smart scooter that is out there. Will not be in that thing. We will not be here to loot the kind of customers that we look at. We are not really to make money as I mean, make money is one part of it. We're not really to put down subscription plans which don't make sense. We'll put out which is there, and we might cover it up also. You never know. So you can look forward for the surprises, and we are here for that. But definitely there will be something that will be in place. To what degree, I cannot really comment on that part as of now. What are the expectations from scrappage policy here? Definitely, that is the greatest move in today's time, I believe, because that was the need of the hour. Automobile industry was shrinking. A lot of job losses were there. This will encourage people to look at new vehicles, and it can be EV vehicles. If people start buying new cars and new bikes and new scooters, demand increases, manufacturing increases, employment increases, the automobile industry goes up. It can add to the economy of the country, and it will be a great push to that. And that is why we welcome the scrappage policy with heartedness. And now at this time, people shouldn't go back to IC engines. So that's something that we should focus on and develop EVs, so that when they start putting out their old vehicles, they can look at EVs than IC engines. What can we expect regarding the development of solid state batteries? Will they be a more viable source? It is too early to comment on it. There's a lot of R&D going on that. See, if you look at any technology, it takes time from a lab to a commercial viability, right? So solid state batteries, they will be, if they come to picture as they claim, it will be a very good viable source. But I think it is around 5 to 10 years down the line, because it is still in early stage. It requires a lot of testings and commercial viability is coming to picture, because lithium ion it was discovered around 90s. It took around, 10 years more, around 2005, 6, it came into picture. So it took around 10, 15 years for it to also come into picture. Now it is more evident, because if you look at the price point of a battery pack, in 2010, it was around $1,000 per kilowatt, right? That was 1 lakh rupee for 1 kilowatt. Today is around 150, $200, which is way cheaper. It is around 9x cheaper today, right? In just 10 years down time. So it'll take time, but yeah, definitely there'll be a lot of advancement in battery technology, and a few of them will come from our end also. So how do you keep yourself on EV technology and industry events? I really didn't get this question. I think the question is about how do I keep informed on EV technology industry events. So yeah, so I'm a very avid reader. I love to read about new technologies, and I make sure I have 1 hour of my daily time invested on reading about different companies, different technologies that is there, and keep an eye on what is happening in the industry, so that we are more informed. And it's very important to be informed, because you never know, technology is changing every other day, and we need to be informed all about everything that we can do. In combustion, we use choke when the vehicle doesn't start. Is there something similar in EV? Unfortunately, no, there's nothing as such in that, because that is a different kind of technology. There's a different, you run out, EVs, if you run out of juice, then you definitely have to charge it and get back. But yeah, definitely, if you can plan it, then you can have a reserve battery, which you can add, if any company, or maybe in future, if there is an option where we can have reserve coming in, then you don't have to use a choke. You can just switch on to the reserve and travel that extra mile that you want to travel. How important were simulation and simulating models in your vehicle development stage? Also, your thoughts on 100-volt plus accumulators on E2 wheelers. The HV wires would weigh less and efficiency increases. Simulation is simulations, yeah, definitely, man. If you look at any kind of simulation that is required today, before we start developing, we do a lot of pre-processing, post-processing. We use Altair, ANSYS, Simulink. Every aspect that is required is going through simulations, and it gives you vital informations. It gives you detailed insights on what the vehicle would look like, end of it, and what kind of durability, strength, the vehicle dynamics, every aspect of things help in simulations. So that is very, 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 very important part of it, and we have invested majority of our time and money on that part to acquire good softwares. Dassault Systems is our a support system, so they have given us a lot of opportunities there, and helped us on the software part of and simulation part too. So we have exclusive teams. These companies also have exclusive teams which help us on that part, and we have an in-house team which is well experienced. It is around 10-member team which works on simulations on these softwares. So we're using advanced softwares to develop our vehicle, and because end of the day, quality matters, and we want to look into developing good products, right? Also, my thoughts on 100 watt plus electronics EV2 is, I would really not comment on this part, because I'm something I look at it as you know not really I really don't have a straightforward answer to that part. So hence I would look into HV wires. Definitely, we have tried this. It definitely weighs less. It's efficiency also increases. Definitely, that is one part of it, and we are testing on those wires. So yeah, that is very good find for us, and yeah, that gives us a lot of opportunities on maybe decreasing the vehicle. What do you say? But wires are not really what do you say, the major weight factors, but obviously having that kind of wires will reduce time, reduce the weight in certain degrees, but efficiency matters. So efficiency increase, so the losses are less. So yeah, definitely we have tried hands on that part. By Nitin Gadkari said that strappage policy will solve the problem of NDFEB magnets, how it works. So it depends on, see, the magnets also, it depends on the kind of motor you're developing, right? So it definitely gives you you know leverage on that part. Scrappage policy will definitely add in that, because we can start developing magnets in the kind of materials that is generated, the raw materials required for it. But again, I would really say that motors are very subjective to kind of application it needs to develop. So I am really not what do you say, very clear on that aspect of things. So I would not really say yes or no on that part. So I would say and the working part of it, definitely, because you can start developing miners in-house, because you have such a abundance of raw material that is being created because of the scrappage policy. You can look into that aspect of things, right? So, but again, that is something that we have not taken root on. But the future will say how really it turns out to be. But on paper, it looks good. Are you guys planning on charging networks in Bangalore? Yes, we are definitely planning on charging network. We have a charge called Matrix, and we'll start putting out our charging stations from May end. That is when we start deploying our own chargers, and it'll be fast chargers, and it'll be open network. So any vehicle come and charge it, and we'll encourage as many EVs as possible to use our networks, because that's a need of things. But again, I would say if you have 240 kilometers of range, or 200 kilometers of range, or maybe 150 plus of kilometers, or whatever range that is there with any vehicle, you would not really look into charging networks, because the purpose is solved, right? You don't have to. If you look at our scooters, 240 kilometers of range that we promise on eco mode, it'll give you 7 days a week, depending on how you ride. So yeah, definitely, but we'll have to build charging networks, and we are on it, and we have developed our matrix chargers. So we call it Matrix. I'm not announced it anywhere, so doing it here now. So yeah, that is something that we're deploying on. How did the testing go on the track? Did the testing meet the simulation results? And thank you for answering. Oh, great. Yes, track was amazing. We are testing it like rigorously. Last 4 days have been very hectic days for us. Today was an off day for on the testing part of it. Yes, we have pretty much smashed simulation results, but again, you see, there are a lot of things that needs to be changed and adjusted and improvised on, because testings are done to improvise the whole vehicle architecture and take data and start making it better, right? So yeah, what we expected, we have matched those things on the kind of tick box. We have ticked all the right boxes that is required, and yeah, pretty much on that. So how
Um,
does Simple Energy plan to
Suhas?
meet the consumer spectrum who spends less than 60K for a vehicle? Home charging probably isn't viable in the small homes. Most two-wheelers in India are parked on the road. How does Simple? Okay, so we are trying to develop affordable vehicles. At the same time, a 60K for a vehicle right now is a bit difficult for the kind of charging infra that is required or the kind of vehicle that is required. Home charging probably isn't viable in the small phones. Not really. Home chargers need to be portable, so I think that is more viable. As I mentioned earlier, we need to develop small chargers, which can be portable. So definitely, portable is an option. A big charger definitely is not viable for small homes. Most two-wheelers in India are parked on the road. Yes, that is one of the concerns uh, which need to be solved, and we are looking into all this aspect. And this is a good insight for me. I think I'll look into this even more clear in our business plans or how we want to venture out. Thank you for your questions. Yeah.
Suhas, thank you for that. We are now going to stop taking more questions. I
Sure.
really appreciate all the answers that you've given, and it looks like we had a very fruitful session as well. So thank you so much for your time. And to all those who joined us today, thank you for joining in and being a part of the Formula Bharat Academy series. You can definitely go to formulabharat.com/academy for sessions that will be happening for the rest of the entire 6 months upfront. And so, as to you and Simple Energy, we wish you the very best going forward in your endeavor.
Thank you so much. Thank you for having me, and it was amazing taking these questions. Majorly, we're on the simple energy part of things, but yeah, good to know that people are enthusiastic about that, and looking forward to having more sessions and interacting with people and encouraging people.
Great,
Thank you so much
great.
for that.
Thank you. Uh, so, I'll just be ending the stream right now. Thanks to all the participants who joined in. So, as just 1 second, if you can wait on the call.